Welcome to John Newton online class. In this video, I want to solve this particular question on the board, which is taken from heat capacity, also involving latent heat of fusion, and that is thermal physics. Now let's look at the question. A block of lead of mass 100 kg in a crucible and at a temperature 50 degrees Celsius was placed in an electric furnace in order to melt it. If the melting point of lead is 300 degrees Celsius, calculate the total quantity of heat required to melt the lead completely. Now, we are given that the specific heat capacity of lead equals 120 joule per kilogram per Kelvin, and that the specific latent heat of fusion of lead equals 2.5 times 10 raised to the power 4 joule per Kelvin. Now, we proceed to the solution. But before we solve it, let us analyze the process. Now, for this lead or this metal to be melted completely, there are two sets or categories of quantity of heat required. One, heat energy required or supplied to do what? To heat it to its melting point first. Then secondly, additional heat energy will be supplied for change of state, that is for melting it completely at that melting point. Now let's proceed. First of all, let us calculate the quantity of heat required to heat the lead to its melting point. So the formula is given by quantity of heat. Let's use H equals mc delta theta, that is change in temperature. The M is the mass of the body. In our case here, the lead metal. C is the specific heat capacity of that metal. Then delta theta here means change in temperature, that is rise in temperature. Now we substitute our values. We have our mass here is 100 kilogram. It's already in standard unit. And even that is in gram, you change it to kilogram by dividing by 1000 times our specific heat capacity of the lead given is 120 joule per Kelvin times the temperature, the final temperature of the lead, which is the melting point, given is 300 degrees Celsius, while the initial temperature before heating was 50 degrees Celsius. Then we proceed. We have 100 times 120 will give us 1, 2, you put the 3 zeros, 1, 2, 3. That is 12,000 times 300 minus 50 give us 250. Then we multiply these two things. Let us multiply it here without calculator. Just take this 12 times 25. Then after you deal with the zeros, since they are whole numbers. 5 times 2, 10. You write 0, carry 1. 5 times 1, 5 plus 1, 6. 2 times 2, have 4. 2 times 1, 2. Then you sum up, giving you 0. 6 plus 4 is 10. You write 0, carry 1, put here, have 3. Now, having obtained 300 from product of 12 and 25, the key numbers there, then the zeros, we just count the zeros and add at the back. That is the short way. 1, 2, 3, 4. To add the 4 zeros, 1, 2, 3, 4. Simple. And that will give us 1, 2, 3, 4, 5, 6. And since we have 6 zeros here, that is what? 3 million. So the quantity of heat energy supplied in the first instance is 3 million joules. And this 3 million joules is equivalent in standard form to 3 times 10 raised to the power 6 also joule. Also, if you want to change it to mega, since it is up to million, 1 million joules equals to 1 megajoule. So it is also equivalent to 3 megajoules. So that is the quantity of heat supplied to heat the lead to its melting point. Now, phase 2. Let us now calculate the quantity of additional quantity of heat energy supplied to melt it at the melting point. That is heat added to melt the lead at the melting point. That is at the change of stage without changing temperature. Okay, that is given by H, the quantity of heat equals to ml. This is the formula, where m is the mass of the lead still, L is the specific latent heat of fusion. Remember, fusion means changing from solid to liquid state. That is this L. Then we substitute. Our mass of the lead is still 100 kg times the specific latent heat of fusion of the lead given in the question is 2.5 times 10 raised to the power of 4. Then, having this now, we multiply them. To simplify it, we just change this one. We can change this one to powers of 10. That is in standard form. It gives to 10 raised to the power 2, which is 100, times 2.5 times 10 raised to the power 4. Then now, following the law of indices here, it will now become 2.5 times 10. You take one of these tens and add the power. That is law of indices in multiplication. 2 plus 4, which will give you 2.5, which will give you 2.5 times 10 raised to the power of 6 joules. Or, remember what we did here, if you want to change it to mega, 60 up to million, or 2.5 megajoules. So that is it. So now, is this the final answer? No. Now, the total heat energy supplied to melt this lead completely as required by the question is the sum of these two energies. Heat energies we calculated. Now we sum them up. Therefore, total heat supplied or required equals the first heat supplied 3 times 10 raised to the power 6 joules plus the second one additional heat 2.5 times 10 to the power what 6 joules. Now, since both of them are in powers of 6, that's 10 powers of 6, that's a million, we can simply and conveniently add them together. Having 3 plus 2.5, that is the rule, but the condition is only when they have the same power. You now have and the same base. You have 3 plus 2, you have 5.5. Then times 10, you take one of these 10 power of 6 as a factor, times 10 to the power 6 joules. Or, if you want to put them back in mega, it can also be 5.5 megajoules. Thank you. I believe you enjoyed this particular solution. For more of these solutions in physics and also in mathematics, kindly visit my YouTube channel. You subscribe, like, and share. Thank you.